In Chapter 4, we're going to be working on graphing linear equations and functions. It all starts with the coordinate plane. And in our last session, I looked to see what you already came to me with prior knowledge on this topic. I asked you to draw and label a coordinate plane in your notes and to tell me what you know about the coordinate plane. And then I asked you to rewrite an equation in function form, something that we've done before. And I'd like to take a look at some of that now. We said that in a coordinate plane, we start off with a number line, and that first number line is my x-axis, and with a vertical number line is my y-axis. The point where these two lines intersect is called the origin, and we saw that it formed four portions or quadrants, and each of them has the capacity to fill in plotted points, and with a positive positive in the first, negative positive in the second, negative negative coordinates in the third, and positive negatives in the fourth. We did a little bit of quick graphing and talked about location. Here are some of the things that we highlighted. That horizontal line was the x-axis, the vertical line the y-axis. Once again, the point where they intersect is called the origin, and that is labeled 0, 0. What do we do on a coordinate plane? We plot or graph points. Those points are ordered pairs or coordinates. And we again refer to those four divisions as quadrants. So before we do any actual graphing, I'm going to give you a graphed line, and I'm going to ask you if you can tell whether the points that are given are points that lie on the line, which means that they are solutions to this equation. I'm starting off with an equation in standard form, x plus 3y equals 6. And it's already graphed for us. Now, two ways I can prove whether this point 1, 2 is on this line and a solution is by actually graphing the point on the coordinate plane. If I go over 1 and up 1, 2, it looks like that point is right there. So if I want to check this algebraically, I'm going to take this set of coordinates, this x and y, and I'm going to replace it into my equation. The equation I'm looking at, or function, is x plus 3y equals 6. So replace x with 1 and y with 2. And we'll simplify. 1 plus 6 is 7. 7 does not equal 6. So we can see both from the graph and from the algebraic justification that that is not a point on the line, and it's not a solution to the equation. Let's try our second point. We'll do that first by graphing. We'll go to negative 3, 1, 2, 3, and up 1, 2, 3, and it does look like that falls right on the line. But what if I made an error in graphing? Let's double check that algebraically. X is now negative 3, and y is a positive 3. We're going to multiply, giving us negative 3 plus 9 equals 6, and our rules of real numbers say when the signs are unlike to subtract and keep the sign of the greater absolute value. So whereas 1, 2 is not a solution, negative 3, 3 is a solution. There were two ways that we were able to prove that one was a number on the line, a point on the line, and number 2, that it algebraically works. Let's just do one more. Here's a line that's been graphed for us. If we were to check it algebraically, we would substitute in 9 for y and negative 3 for x. And then we'll simplify. We can also do the check by going over 1, 2, 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like it's a point on the line, but let's follow through on the algebraic end. And we can see that 9 equals 9, so yes, that's also a solution. Two ways that we can graph. Now, a line has infinite amount of points, so how will we go about graphing the line? We're going to start off by using a table of values. We call it an input-output table, we call it a function table, and we're going to take an equation, and if it's not already in function form, we're going to need to first rewrite it. And we've done this before. We'll isolate y. So when I isolate y, I get y is equal to 2x plus 3. We're going to find that there are several ways to graph a linear equation. The first one is with this table of values. So now that we have our equation in function form, we're going to be given a domain. Think back to those words, domain and range. Domain was my x values. If I give you the x values or the input values, you're going to use that rule to come up with the y values. What will that give us? Ordered pairs, and ordered pairs can be graphed on the coordinate plane. So this is our first method of graphing a linear equation. Go ahead and now complete the table, one value at a time. When x is equal to -2, that's -4 plus 3 is -1. My first ordered pair is -2, -1. Second value, I'm going to replace x with -1, and that gives me -2 plus 3 is going to give me a +1. So when I input, I output. 2 times 0 plus 3 will give me 3. My pen is acting strange today. Okay. Then I have 2 times 1 plus 3. Input 1, output 5. Let's complete this table by inputting 2. Input 2, output 7. And again, I had given you some graph paper. You can easily start plotting these points. And again, you need to know something about where points are located. We start at the origin, we're counting over 2 and down 1. We have over 1, up 1, 0, 1, 2, 3, 1 and 5, and 2 and 7. And then you connect the dots. Okay, so as we're looking at that, we see that we have successfully graphed this equation. Let me just get that line a little bit nicer than that. All right, that's a little better. Now, when we're graphing a line, we're also going to remember it is a line, so there should be arrows at both ends. And you now graphed your first linear equation. Let's take a look at a second table of values. We want to be able to do this with relative ease. Noticing again that this is not in standard form. I mean, it is in standard form, so we need to put it in function form. We'll start by adding 4x to both sides. We'll divide by 2 and we get y is equal to 2x minus 1. Go ahead and complete the table on this one and see where it takes you. And we'll check this one in class. So you should be able to complete a function table and graph the points. That's our first mission. I mentioned some of these words before. Here's a third example for you to try, but we want to start by rewriting the standard form of the equation to function form and then set up the table. Most of the times we'll be given a domain values. What's the domain? It's your x values, your input, or your independent variable. Your job is then to come and get your y values. So once we have our x's and y's, our ordered pairs, we will plot those points. We'll connect the points, and we'll have the graph of an equation. And that's all there is to the first section. Now, I mentioned 2 other ways that we're going to be graphing linear equations, and you already had a hint at the graphing using the x and y intercepts, and that'll be our video lesson for our next class.